I got stuff for you.
Holy moly. I need to get some snakes and release them around my house.
But they love eating people. They love eating kids.
These guys are the scientists of the supernatural, lecturers leaving lessons for inquiring laymen. They are applying the scientific method to a world that baffles science. They are the cryptids of the corn.
Every day that you open your mouth,
I know, right?
I'm more convinced that you're abducted by aliens.
No.
And it just stood up. I mean, it just like kept going and going. And she goes, what the?
These are idiots.
I was laughing reading this because I already knew how you would feel.
Idiot. What part of the story fits your balloon?
Well,
This isn't a UFO. But who else has big black wings and red eyes?
Batman.
Well, Mothman.
Oh yeah, Mothman.
Well, everyone, I think we know exactly what it is. So say it all with me. It was the sandhill crane.
Would you try it?
No.
You wouldn't eat it?
No.
Why?
Because they're probably toxic. There'd be a lot of poop in my pants. I've seen a 6-foot alligator go swinging through the air and slam into a tree. Welcome back to Cryptids of the Corn podcast. I am the great and Planarian Mr. E.
Oh, wow. I'm J-Clone 12.
Yes. You sure you're not 11?
I'm sure I'm not 11.
All right.
I feel a little flat today, though.
All right. We're not alone. We're joined by an amazing guest, an accredited guest. We're super, super excited to have
I'm very
him.
excited, yeah.
All right. You're going to do the intro.
Okay. We are joined by an accidental Planarian biologist and listener of the show, Oné Pagan.
Welcome.
Hello, guys. Thank you for having me on. I'm very excited about it. I've been a listener for some time. And just to get it out there, I am kind of a skeptic by temperament and training, never a debunker. Never ever a debunker. I'm comfortable with the fact that we don't know everything about nature.
Mm-hmm.
Okay, so yeah.
All right, that's so nice to hear from a biologist such as yourself. We worked in the field, and I know you know people, and I know people that are high-level biologists that feel the exact opposite. So,
Yeah, what can I tell you? I mean,
yeah.
hubris.
Probably clean biologists.
Clean biologist. Oh my gosh. There you go, Ralph. You laugh because he laughed?
Yeah.
There's like 80 people that know what that joke means.
Yeah, I know. You're the first one to laugh back.
No, I'm super excited to talk about your work. When you reached out over the email, I was actually still up at the Toledo Hospital, I think, when you reached out, or the week I went up.
Yeah.
And we made this date, and it happened to be perfect because the twins were born, and we were home. So I was like,
It worked out.
we didn't have to record in a broom closet in Ronald McDonald House. But your work absolutely fascinates me, and I can't wait to learn more about it. The accidental Planarian biologist.
Well, yeah. Should we explain to people that are listening that don't know what Planaria are?
I'm going to let him do it.
Okay, yes. Maybe that's a job for you, Oné.
Yeah. Oné can describe what a Planaria is. We talked about him in our consciousness episode.
Yes, that's right.
Okay, so essentially, planarians are flatworms. That's all. That's all it means. But there are three main types. There are terrestrial flatworms, which are an agricultural pest because they eat earthworms. So they affect agriculture, all these type of things. There's also marine species and freshwater species. The ones that I work with are the freshwater ones. And of all things, I use them in neuropharmacology. These are the worms that you can cut their heads off, and they will regrow their heads off, including the brain, correctly formed.
Wow.
So imagine if we ever are able to learn how to do that. Think about people with, sadly, brain damage because of an accident, okay, or spinal cord injury, Alzheimer's, Parkinson's, any type of neurological disease. So these critters are able to reconstruct a brain correctly. Mind you, it's not uncontrolled cell growth, because uncontrolled cell growth is cancer. Nobody likes that.
Mm-hmm.
Okay, but these little guys are able to do that. And from maybe in the last 30 years or so, including my own research group, we are using them in pharmacology, and particularly neuropharmacology. That's the short story about planarians.
Is that only freshwater species that can do that?
No, actually, no. As long as they're flatworms in the phylum, they can regenerate with
Wow.
different abilities. There are some species that are very flimsy at doing that, but for example, the ones I work with, they can regenerate a full head within a week. So
Wow.
something like that.
That's crazy.
And
Yeah.
how the genome map to to regrow all those like the vital organs, and that's why I love him so much. The consciousness episodes are the only episode we really got to go into them. But having developed organ groups and being that simple, and being so complex, they've always fascinated me, and I'm so excited to have you on to talk more about it. Now, this is your show. You can take it any.
Oops.
Just ignore that when that happens. You can take it anywhere you want. Do you want to talk about how you became the accidental biologist first, or do you want to talk more about your
Absolutely.
work first?
I can do that. I can do that. I have to start by saying that I was a non-traditional student, because usually when you see a scientist out there, they do their undergrad, maybe they do a master's and they go ahead for the PhD. But I didn't take that route because of life, essentially. I did my undergraduate degree in general natural sciences. I took astronomy, I took computer science, I took, like, of course, biology and things like that. And then I did a master's in biochemistry. Okay. But between the bachelor's and my master's, I did work, right? I needed to work. I met my wife. We started having our kids. She helped. She did most of the work, as you well
Yes.
know. And always wanted to do my PhD, but I needed to work. I had a family. Okay. So I was working at a medical school where I did my master's. I was a research technician there. But then when I was 34 years old, a collaborator of my mentors, that was in Puerto Rico, by the way. I'm Puerto Rican, born and raised. So I did my bachelor's and master's in Puerto Rico. This collaborator of my mentors came to the medical school, and we got to know each other and whatnot. And he invited me to apply to his institution, which happened to be Cornell University in Ithaca, New York. I applied. They offered me a scholarship, and I told my wife, "It's freaking Cornell." Okay, so, and we moved to the mainland. And our youngest son was born in Ithaca, and I did my PhD there in pharmacology with a neurobiology emphasis. At the time, I knew what planarians were because of, as an anecdote, quote unquote, but I never took a zoology course. I didn't, nothing like that. My main focus in my PhD was, well, I did my PhD in a physical chemistry lab. And I was doing pharmacology and neurobiology and whatnot, studying the protein to which cocaine binds to. Okay. But I was doing like biophysical studies, biochemical things like that. Okay. In 2001, this happened almost 20 years ago, a paper appeared about planarians being able to get addicted to cocaine, meaning that they would give cocaine to planarians, they take the cocaine away, and they will go into withdrawal. Like they will swim like crazy, they get the shakes and whatnot. So I went to my advisor, hardcore physical chemist, okay? And I told him, I used to call him George because in grad school, the grad school I went in, they have a very informal, you don't call them doctors. They don't like them to call them professor. So he asked me to call him George. George, I want to study this system. This would be a great thing to do for my thesis and whatnot. And he said, no. He said, when you have your own lab, you do it. And that's precisely what I did. When I was hired at my current institution, this is what I've spent all of my post-PhD professional career, Westchester University in Pennsylvania. I educated myself. I learned about invertebrate zoology. I learned about planarians. And I started to design experiments. And almost 20 years after I began working here, if I say so myself, we are one of the few labs who are leading the way in Planarian neuropharmacology. And that's in great, biggest, the most part, thanks to my students, my research students. They are fantastic.
That sounds awesome.
Amazing, yeah.
Yeah. And that's how you became the accidental planarian biologist.
Yeah.
That's why I'm an accidental planarian biologist.
Stumbled
Yes.
right on it.
Now, and it's funny about the undergrad and, picking your thesis and stuff like that. I have a buddy going through it right now. Oh, but did you meet Zach last time he was up?
No.
You know Zach, though.
I know of him, yeah.
And he went to a lab for a completely different thesis. And when he got there, he was told that he was now doing rainbow shiner speciation.
Okay.
That's not what he went there for,
Mm-hmm.
but he was already there. So then he had, so that's just made me laugh because it's just, he had, a similar experience that he was doing something, he wanted to do something completely different. And, but he still likes rainbow shiners. It just,
Who doesn't like a good shiner?
yeah. Well, yeah. Who doesn't like, I guess, fish,
Yeah,
not
when
banana.
you go to grad school, you kind of have to do what your advisor tells you to do within reason. But the beauty of being in academia is that once you get your own lab, you do whatever the heck you want.
There you go. Now, I'd love to hear more about your experiments and what you're finding with these planaria, because I'm just infatuated. I'm super excited.
So am I. Thank you. So, what would you like to know?
I don't
guess-
even know what questions to ask. Just tell us more about planaria. You're specifically what experiments?
Yeah, what
are you doing? What are you finding?
current research like projects you're working on or things you're shooting
so
towards?
Basically, what we are trying to do is to establish the Planarian model as an animal to study neuropharmacology.
Okay.
You would be surprised to know that they have a relatively developed nervous system with a brain that is similar to ours, two lobes in the brain, but instead of one spinal cord, they don't have a spine, but they have one nerve cord. They have two, one for each lobe. Okay, so that's one thing. They have pretty much the same cell types as we do, and they respond to most of the drugs that we respond to, specifically abuse drugs, in the same way as we do. I already told you the story about how they can get addicted to cocaine. Same thing with nicotine. Same thing with many other compounds. And one of the things that we are doing in the lab is to try to come up with substances that may serve as antidotes against acute toxicity for abuse drugs, nicotine, cocaine, things like that. We have already found one that I have actually tattooed in my arm.
Oh, he does.
I'm full of surprises, let me tell you. So the compound that I can that I have in my arm is called parthenolide, and that has an interesting background story about it. Long story short, this is a behavioral antagonist of cocaine in the Planarian system. Okay, we are. Oh, by the way, I don't have cocaine in my lab. The cocaine is in another building under lock and key. I don't have the key. I have, just to throw it there.
There's a lot of rules when doing any kind of experiments with any kind of controlled substances and stuff like that. Yeah.
So, but what we do is to, for example, give the compound to planarians. We observe their behavior and under acute and chronic administration. Acute will mimic like toxicity, like overdose, if you will. Okay, and sublethal concentrations to mimic addiction, and then we add compounds to try to counteract that. Parthenolide just happens to be one of those, and our current focus is nicotine and related compounds, including a type of pesticide that it's derived from nicotine. They're called nicotinoids. And they are very useful agricultural pesticides, but they leach out into aquifers and freshwater systems and whatnot, and they target non-intended targets like planarians and, crawfish, shrimp, things like that. So we are trying to develop methods to counteract pesticide effects on planarians and eventually learn about the nervous system. One thing that we are getting into is the pharmacology of regeneration. We've already developed in our group a behavioral test to assess regeneration in planarians. We are not the very first group to deal with regeneration in planarians, but we are one of the groups that are applying pharmacology. to that.
I got some questions. That's amazing what you just said.
Yes.
A lot of questions.
A lot going on. I can see your
Oh,
gears
yeah.
turning.
Yeah, no, I'm excited.
I can talk for, Captain America. I
Yep.
can do this all day.
Yep.
That's me.
Oh,
So-
okay.
Well, first, that's awesome. So first kind of one, with the two separate nerve cords, are they still functioning in tandem, or is it more like there's two brains there?
That's a very good question. The short answer is that we don't quite know, but I can tell you that the two nerve cords are joined by secondary nerves in a ladder-like
Okay.
structure. So if you disrupt any of the ladders, you disrupt their behavior.
Okay.
Oh, wow.
Okay. So that I mean, they can regenerate very easily.
Yeah.
But again, their nervous system must be intact for them to do their thing. But the beauty of that is that it doesn't last for long, any damage, because they will repair pretty
Yeah,
much
it'll bounce
everything
back
that we can
fast.
do to throw at them.
That's awesome.
Another thing that they do, especially freshwater planarians, they don't seem to age. All the biochemical markers of aging that all animals do, they don't seem to exist in planarians. So theoretically, they could be immortal. They're easy to kill. I mean, you can squish them. You can add some chemicals and dissolve them. They will die. But if left alone with food and whatever, they don't seem to age.
So
And really, nobody knows why.
yeah, that's if I'm not mistaken, the age thing's very similar to like the immortal jellyfish. You know,
Something like that. But they don't go back.
They don't have to reset.
babies and
Yeah.
they grow up either from a fragment or hatch from an egg. They can reproduce both ways, and once they reach adulthood, they stay happily. They swim happily.
So,
awesome.
so if you take one adult one and you cut it in half, doesn't matter what way, will both halves reform?
Actually, you can cut them in like 200 pieces. Okay.
Okay.
And if you leave them alone and put food in the media and whatnot, each of those pieces will regenerate into a complete worm.
That's so. Are they like biological clones, basically?
Yeah, exactly. Because each you can
should know.
you can create like low cost clones, no molecular biology involved. Just cut them in half. Same genetics.
See, the thing is, I do know I'm testing him, so he passed. He passed.
No. I know you're just asking me questions to see if I know what I'm talking about.
Right, you're passing the sniff test.
now I don't know if you when we did our consciousness episode, we brought up a different group's study with them with training some planaria, and I believe they were land planaria, but I don't remember anymore. With the mazes, right? And they'd cut one off, like the tail piece, and it'd regrow, and it would remember the maze.
Oh, that was freshwater planarians,
It's freshwater.
and I'm a colleague of that research. Actually, I'm writing a book with him.
Wow.
I'll buy a book, and I want it signed, just so you know.
No, you count on it.
we've covered his
name is,
work already.
His name is Mike Levin, and I'm telling you, can I say bad words here?
Yeah, you're good.
Okay, he's gonna win the fucking Nobel Prize at some point. Okay, he's fantastic, and in addition to that, he's a really nice guy. Really nice.
That's
guy.
good.
And
Yeah.
we've been colleagues for years, and he actually invited me to write the book with him. And I didn't tell him in so many words, but I was like, "Fuck yeah, I'm gonna do it." Because how could I pass that opportunity? It's about bioelectricity and development.
I'm
It's-
excited.
and it's gonna be popular science. I'm super enthusiastic about that one. So
I can't wait.
That's really exciting.
Another thing I had written down. So, is the goal with the planaria with the withdrawal symptoms and these compounds to help, get them over that? Is that a goal for human medicine?
my main goal is essentially as an antidote, because addiction is a very complex thing. You can get addicted to anything, like I don't know, coffee, okay, sex, gambling, all right, but and it's very hard to address the fundamentals of addiction in that moment. But for toxicity, it's relatively easy to do, to try to identify compounds that can serve as antidotes. But for example, there's antidotes for opiates. When a person gets overdosed with heroin, okay, we have Narcan or naloxone. That's an antidote that takes the person out of there. But there's nothing like that for cocaine overdose. Okay, so and that's something that in the long run, we would hope to address. But I'm not a clinical pharmacologist.
Right.
No, I'm not a human pharmacologist. Well, you know what I mean.
Yeah.
Yeah.
I am a
You know-
human, pharmacologist.
Pharmacologist.
Yeah.
Wait, he covered his track real fast.
Yeah,
there.
yeah.
Real quick.
I've done that before. Yeah. No, that's awesome. That's why I find them so fascinating personally. Is like we said, they're for how simple they are. They're incredibly complex.
Absolutely. Absolutely.
The age thing I wanted to ask you about. So they're essentially immortal, like you said, in perfect working environments. If something doesn't eat them or something doesn't dissolve, that kind of stuff. How old would you? I don't know. How old do you personally think they can get? Do you really think they're an ageless being?
I said immortal, quote unquote, because sometimes you hear scientists say, "Oh yeah, Planarian are the only immortal organisms," but we haven't done the experiment. Okay,
Right? How are you going to do that? Yeah.
There's not a 500-year-old Planarian around, but I know that people have made colonies that have lasted at least 30, 35 years long, something like that. That for an invertebrate, tiny thing that is about a centimeter long, about the length of a fingernail, that's pretty good.
That's a long lifespan for something that tiny.
Exactly. So, I mean, for all intents and purposes, they could be immortal, okay? But I'm comfortable saying that they are very long-lived.
Yeah.
Way more than what you would expect from such an organism.
I mean, when you look at them, like they're much more complex than like we have barrel sponges that I believe that some scientists estimate 10 or 11,000 years old, but they're a sponge.
Yeah.
So for something like
no nervous system to speak of.
Yeah.
No brain. Yeah, I get what you're saying. Yes.
Yeah, for flatworms having, hemispheres of the brain, like they're very, it's just, I love
Complex,
it.
yeah.
I'm so excited.
Yeah.
But no, that's interesting. And then, because tons of people, it depends on what biologist you talk to. I know, but everybody has different opinions on what it means to be immortal, I guess. It's a hot button topic when you talk about, if you talk to any of the crayfish people, they'll tell you lobsters are. As long as something doesn't eat them or they don't die from shell rot.
And then you talk to celebrities, you get a whole other answer in general.
Oh, yeah, that's virgin blood.
Oh, okay, yeah.
And so you talked about saving or reversing some basically toxicities that leach out into the environment, like you were talking about flatworms, crayfish, and all that stuff. You okay?
Sorry, it's virgin blood. Like,
Oh, just out of nowhere.
The clone is degrading.
Yeah. You see that? Too much. That's too much cocaine.
Actually, I can tell you that planarians, when they die because of a chemical in their environment, they die dramatically. They actually dissolve,
oh wow.
like in a monster movie or something
Yeah.
like that. So they dissolve and they,
Leave no
turn into nothing.
yeah, like a salamander.
Like salamanders dissolve really fast. It's crazy, but
Yeah.
not like that. Like
Oh, okay.
they just die and then
Turn to dust
Then they
and-
rot.
Yeah.
But yeah, so you're talking about some like working on compounds that may save some environmental crises, with pesticides and stuff like that. I'd love for you to maybe talk a little bit more about it because that's something I find fascinating. Working on the other end, dealing with I dealt with cleanup and checking on stuff after the fact. We only ever caught in my work 3 companies that were in the process of actively destroying the environment. A lot of times we were already too late, and fish have tumors the size of softballs.
Oh my, that's a big problem. Yeah. Well,
Yeah.
I could tell you a story. It's
that's
horrible.
an understatement.
right outside of a-
But yeah. No, but basically we are at the very preliminary stages of this type of research, and what we are taking, well, predictably, that's kind of what we do, taking a pharmacological approach. By the way, don't tell anyone I said this, but toxicology is pharmacology's little sister. So that's. But if you ask a toxicologist, they will take issue with that. But they use all the same principles.
Right.
Yeah.
Basically, the main idea is that we are starting from the point of view that the nicotinoids, let's say that these are the nicotinoids, they bind to a place on a particular receptor to which nicotine binds to. We call that the nicotinic acetylcholine receptor. Okay, so it's the same receptor to which, again, nicotine that we some people smoke bind to. We have that type of nicotinic receptors in our muscles. They are the ones responsible for muscle contraction, but we have versions of those in the brain and central other places of the central nervous system. There's hundreds of types of these nicotinic receptors. All of them, most of them, I should say, bind nicotine in a pharmacological manner. So what we know that planarians, they display pretty much the same type of receptors as we do. Maybe a little less variety, but very similar nonetheless. What we do is to expose planarian to sublethal concentrations of one of the pesticides. Okay, there's many of those nicotinoids available. We measure their behavioral responses at sublethal concentrations. We do the experiments to reach lethal concentrations to get our curves and whatever. And then we add compounds that act as antagonists of those nicotinoids, mainly that they will displace it from the receptor sites to see if we can counteract those effects. Will that be useful, wholesale in a lake? We don't know. We don't know yet. But we are trying to establish the basis for a pharmacological dissection, if you will, of such compounds within the Planarian system. And we have a couple of candidates. Actually, one of them, it's called cotinine, which is a metabolite of nicotine. We all degrade all the compounds that we ingest. Okay, that's part of metabolism. Okay, because the body wants to excrete them. Nicotine is metabolized into a variety of compounds, including cotinine, which only differs from nicotine in one freaking atom. That's the difference. And yet that compound, it's able to displace nicotine from its binding site. We are hypothesizing that compounds like this, like cotinine, should be able to displace nicotinoids from their targets. Okay, and we're beginning to study regeneration in the presence of nicotinoids to see if they affect regeneration. We are hypothesizing that they will slow down regeneration, but we don't know. We don't know yet.
That's amazing. Do you get what he's saying?
Absolutely.
Okay.
Yeah.
I find this so fascinating.
Yeah.
So he's basically like, for everybody at home, I don't even know where to go with it. I'm just
basically, so if you smoke a cigarette or ingest nicotine, you have these receptors in your body that the nicotine attaches to, and then your body can absorb it, right?
Well, he's talking for pesticides is what I find fascinating because I dealt so much with pesticides.
He's kind of using the same principle.
This could keep these species from uptaking pesticides,
right?
And keeping environmental, if it works for all these species, safe from these pesticides,
preventing their bodies from absorbing it. Like,
is that correct?
That's the thought, maybe? Exactly the idea. And we have to. I forgot to mention that we have to begin from the start, from a starting point, that pretty much all substances that plants make. Okay, we're talking nicotine, we're talking cocaine, we're talking morphine and whatnot. They are natural pesticides. Right?
Yeah.
Because, for example, a tobacco plant does nothing with nicotine. Nicotine does not contribute to the tobacco plant's metabolism at all. Okay? On the other hand, you take chlorophyll out of the plant dies. Okay?
Mm-hmm.
So why would a plant make a compound that they are not going to use? So the evolutionary interpretation is that they are, again, natural pesticides. You have a tobacco plant. So you have a little bug that nibbles on the plant, ingests an amount of nicotine, and it poisons it. It dies. But the same amount of nicotine that is ingested by a smoker, for example, because we are much bigger organisms, and yet we have similar receptors, it causes psychoactive effects on us. Okay? And that's the general theory of all the Ines, like nicotine, cocaine, morphine, and so on and so forth. They are natural insecticides, essentially. But because we don't ingest them usually in toxic concentrations, we get or high or certain behavioral effects, things like that. But they are pesticides in their own right.
Yeah, that's amazing.
Well, how are we supposed to eat the bugs in the future if We have, morphine and cocaine and.
I mean, even like peppermint oil and stuff like that.
I'm just messing with Eats the Bugs.
Oh,
I just
yeah.
wanted to say it.
Listen, if let's suppose that you like your pizza with pepperoni, a bunch of plant stuff, peppers and whatnot. Most of the substances that give flavor to peppers and whatnot, they are intended as pesticides too. It's just that we happen to like it because of they don't kill us essentially.
It
But
takes
they are
so much.
plant defenses.
Yeah, that's awesome.
Wow.
I mean, that's capsaicin in peppers.
Right?
It was made to not make you eat it, and then some of us are like,
Hey, I like this.
"That's really good. I like it hot."
Some people enjoy the abuse.
Yeah, you do.
Actually,
No.
a tragic thing that happened with one such thing. There was a kid who actually died because of one of these challenges or trends to eat one chip with a really high concentration.
Oh, yeah.
The
The
one
one
chip
chip
challenge.
challenge.
And he died.
Oh,
Sadly.
yeah.
It's not a smart trend.
Yeah, no.
Capsaicin is toxic, like you said. It is. It's a plant toxin
Yeah.
to keep things from eating it. So you can he died from it, but it's toxin.
Right, yeah. We'll just eat a bucket load's worth of powder formed of it.
Yeah, I wouldn't do that.
Wonder what would happen.
No,
No,
I love this so much. This is so fascinating.
Yeah, it is.
You got a question for him?
Yeah, I mean, I guess essentially, so with, I like how your speculation on it might slow down their regeneration. I'm curious to see how that does turn out. I'd like to know if you're right, or what if it doesn't slow down at all? That's a interesting result as well.
I'll certainly keep you posted because we like to publish as many things as we can from the lab, and trust me, you'll learn about it.
Absolutely. What's your lab called again? So is it something we can look up and see what you guys are working on or put out previously?
I'm based at Westchester University in Pennsylvania, and if you go to the Department of Biology, there's a website where with the websites of each faculty member. I can send you the link if you'd like.
We'll put it in
Absolutely.
the description below.
Yeah.
Anyway,
And I'm in a couple of other places. One's called ResearchGate, that is like a social media for scientists type of thing, and it's super geeky. The only social is to exchange papers, and things like that. So I can give you these type of things.
I used to go to the National Fisheries Conference. I know it. Super geeky.
Yeah.
Yeah.
I'm an unapologetic science nerd. I mean, I just happen to like biology a little bit more. But one of the courses that I teach is kind of, of course I teach pharmacology, but one of the course that is a favorite of mine is astrobiology. I co-teach that with an astronomer friend. He starts with the Big Bang, formation of planets, galaxies, all these type of things until life appears. And then I take over. So I talk about the origin of life, evolution, and we end up speculating about life elsewhere.
I love it.
It's a really cool course. Yeah.
Yeah.
And
Astrobiology. I love astrobiology, theoretical biology.
I was going to say theoretical cosmic biology.
Well, we talk about it a lot on what we talk about a lot on the show is speculative biology.
Yeah.
Speculative, yeah.
Yeah, that now I got to ask because you brought it up. Are fungus a part of our biological tree, or are they like a shadow biosphere from a meteorite or something like that?
Well, evolutionarily speaking, we are all related to fungi, and in fact, you guys probably know this already. Fungi are more closely related to animals than to plants.
Yep.
Okay, so that's one thing. Because in the endosymbiosis, formation of eukaryotic organisms and whatnot, you know that first we got bacteria into another archaean, another prokaryote, and we got the first eukaryotic organisms, like with mitochondria, stuff like that. Then in a second, from that, animals and fungi came along. Then from a second endobiosis event, cyanobacteria became the chloroplasts and whatnot. So they are very much from Earth. That reminds me of some really weird speculation, and I'm trying to be kind here, of some people who argued that octopuses were aliens. So No.
Simple
Every
answer.
evolution, every genomic test and whatnot. Yes, they have a very unusual genome. Yes, they have unique characteristics. Yes, they are incredibly intelligent. Yes, they evolved on Earth. Okay, so that's the best. Maybe tomorrow they discover something differently, and I will be the first to one. Yeah, sorry about that. You were right.
Till the ship lands and octopus walk out.
Yeah.
We're like, hey, we left some guys here.
Yeah. You might change
Yeah,
your tune.
yeah. I would welcome our octopus overlords.
No, it's interesting. Fungus. You know, that's another one that's always fascinated me with how incredibly complex, similar, and alien they are to us.
Yes.
With high
And let's
feed.
not even talk about their psychoactive properties. Okay, because you eat a mushroom, it can kill you, it can make you high, or it can nourish you.
It can heal you. You can talk to people from another dimension,
You know what I always say?
or you can bleed from every orifice on your body until you die.
Yeah.
Life is like a box of mushrooms.
You never know when you're
I'm
going
sure
to get.
I'm sure you have heard about the stone ape theory.
Yeah.
Oh, yeah.
Okay, so that's very controversial, but it has some I
Merit.
don't know. It rings kind of right, as it were. Okay, but there's a prior. Actually, it came a little later. The drunken monkey hypothesis.
Okay.
Which essentially states that primates and monkeys in particular, they develop their taste for alcohol on a nutritional context. Okay, one of the first things that your doctor tells you when they want you to lose weight is to, well, don't drink alcohol.
Right.
Okay, and you're talking to a person who gets high with a beer. Okay, my limit is one beer when I'm mowing the lawn, things like that. So the drunken monkey hypothesis states that, again, primates develop a taste for alcohol when they ate a fermented fruit, and that allowed them to survive because of their nutritional value. And of course, those animals that survive pass their alcohol-like genes in future generations. So that theory has a much more experimental evidence than the stone ape theory. But they are incredible examples of how animals can get intoxicated by the same substances that we do. Okay, so that's yeah.
For the fermented thing, I could speak on it with cattle. So fermented foods tend to be more nutritious, like you're saying, for animals. We ferment hay on purpose over the winter, so it's more sugar. There's more sugars in them for cattle in the spring and the summer.
I just watched a video too about a lady fermenting her chicken feed before she feeds her chickens.
And we're not talking like, modern day fermentation is very different than that kind of basal fermentation.
Right.
You know, when you're making Everclear.
Not like that, yeah, but fermenting nonetheless.
Yeah, no, it's ferment. It's more basal ferment because we used to do that with our chickens, with soaking grain and stuff like that.
That's what she
did.
did.
It unlocks a lot more sugars.
More nutritional for the animal.
Yeah, we now we cook our food, which unlocks nutritional benefits and stuff like that.
Or erases some.
Well, I'm not saying it doesn't get rid of some compounds, but it also unlocks some proteins and stuff like that, fats.
I'm just being
a contrarian.
Yes.
Yeah, I'm aware.
Oh, okay.
No, that's awesome. Do you have a question?
Oh, not right now. I'm fascinated listening.
What else you got? I'm ready to keep listening.
Well, you want to hear about some other animals that getting intoxicated kind of on purpose?
Yes.
Yeah. Okay. So I don't know how much you look about my publications and everything, but recently I published a popular science book in that topic. Am I allowed to plug it in?
You plug
Absolutely.
everything you want.
Okay. So you probably can see this. The publisher sent me a poster. I'm not that narcissistic. They sent me that it's titled "Drunk Flies and Stone Dolphins: A Trip Through the World of Animal Intoxication." And that the origin of that book is because of the Planarians. Because I got into thinking that what if my Planarians can get intoxicated by nicotine, cocaine, and whatnot? I've heard stories about animals that can get intoxicated too. And I educated myself and I discovered so many things that I just needed to write a book. So did you know, that's my favorite question. Did you know that fruit flies, male fruit flies, when they fail to get female companionship, if you know what I mean, they prefer fermented fruit as opposed to fresh fruit. Okay, they get rejected, they drown their, sorrow.
Sorrows.
And alcohol.
And again, I'm
Tale
not
as old as time.
criticizing or making fun of that. Addiction is a very bad
Yeah,
thing.
right.
Yeah, oh
right.
yeah.
But I mean, if we can educate people in these type of things and find some humor in it, is a way of learning. So fruit flies are able to do that, but it goes beyond that, because then female fruit flies, they lay their eggs on purpose on fermented fruit, so that alcohol can prevent parasites and entities like that from eating their eggs. Okay,
Oh.
how can that evolve? These type of behaviors. So it's super interesting, super interesting. And of course, we have all heard the stories about catnip,
Yep.
right?
Oh yeah.
All cats, from the biggest cats to small the house cats, they can get about 70% of the population of any type of cat can get intoxicated with catnip. And I can give you an autobiographical example. My daughter, well, my little girl, she's 33. I don't know when that happened, but you know what I mean. So she has three cats now, but prior to getting her third cat, actually, I put that story in the book because her two cats react very differently to catnip. One of them, the male one, and it has nothing to do with the sex of the cat, but just happens to be like that for my grandcats, actually. Uh, when the male gets catnip, he reacts like the stereotypical high person. Okay, he looks at the ceiling, he starts meowing like meow, like this, looking like at stuff. The female, she gets ballistic. She starts running around in circles as if she were being chased by a bear or something like that. Okay, so that's an aspect of pharmacogenetics that happens to you or me. What the same person, just like I told you before, I get dizzy with a beer. Okay, some
Right.
people may need more than one beer to get dizzy.
Right.
Okay, so and that's another example. Big cats like tigers, lions, and whatnot, about 70% of the population can get high with catnip. Okay, so and there's so many other types of animals like horses on loco weed. Okay,
Yep.
have you heard about loco weed?
Yeah.
Yeah, okay. So they nibble on those plants and they get crazy, essentially. So and there's so many examples. The tail part of the book, the stone dolphins, that was kind of the most frustrating part of the book to write, because I am fastidious about documenting my sources. Okay, first because I don't want anybody to think that I stole the material. It's a point of pride
Yeah.
for me. And second, I want to write something that is, to the best of my knowledge, factual. Okay, and there's so little about these stone dolphins. The thing is that a few years ago, a documentary filmmaker, they wanted to do a documentary on dolphins and whatnot. So they went underwater and they were filming a pod of young dolphins. They observed that they were catching pufferfish, okay? But they didn't kill the fish. They just nibble on it, give it to the next dolphin, nibble on it to the next dolphin, as if they were passing a joint, something like that. And the documentary filmmakers they actually observe, they say that they observe that the dolphins, for all intents and purposes, they look high. Okay, but the thing about it is that there's no known evident psychoactive substance in pufferfish, except maybe for one. It's called tetrodotoxin.
Yeah, we talk about that a lot
A
on the
lot.
show.
Yep.
Oh yeah, so tetrodotoxin is a really nasty toxin. Okay?
Yeah.
There's no antidote. Okay, and there's some evidence that it's psychoactive in humans in small amounts, but there's not a lot in there. That being said, one speculation may be that the pharmacology of dolphins is slightly different than ours, and they can get actually high on tetrodotoxin, or that they are so big animals that the same concentrations that will kill a human
Just won't kill
will
them.
get a dolphin high. Okay, so the craziest thing is that that pufferfish is a delicacy in Japan and countries like that. It's in fugu, and to become a fugu chef, I was told that they need to get like a university degree.
Yeah, it's
I don't know how true this is, but I'm told that the final exam is for them to cook a fugu meal and they have to eat it.
yeah. I
Okay.
think there's a Netflix documentary about that. How do they? Because there's
okay,
only
I didn't know that. Okay.
there's only like 100 of them, like of the masters or whatever in Japan. Like it's super. Like it takes a lot to get there, and you got to train under them. Yeah, and they do.
yeah.
They make. I think you're right. They make you eat your final exam because if you fail, then it's on you.
You ain't killing nobody else.
That's what I tell my pharmacology students. You think my final is hard?
There you go. Go to Japan. They'll make you eat your final.
Yeah. I think all science should do that, especially when they're rolling out new medicines that they force people to take. Just try it yourself first. Let's
There you
watch.
That used to be the case historically for chemists and whatnot. They used to taste everything.
Yes.
If you ever took chemistry in high school or in college, now there's a lot of security measurements. You don't pipette anything by mouth. That didn't fly 200 years ago. They will actually lick metals and stuff.
See,
So
Gallium and all
chemists had
kinds
a historically short lifespan.
those,
Well,
That's
Marie
those are those-
Curie is a good example.
those are those dirty, clean scientists.
Yeah, they were dirty scientists.
Yeah.
Madame Curie literally had the ring made out of a radioactive isotope
Yeah.
that when she was discovering radiation, and
Yeah.
the pictures of her hands are just like bone spurs. Tetrodotoxin. We mentioned on the show. So I used to breed rough-skinned newts, and they leak tetrodotoxin. They're the most. You probably know, but they're one of the most poisonous vertebrates on the planet. So not like puffers where they just have it in certain parts of their body and then they can release it.
Yep.
These guys are just. They'll literally sweat it out when they get stressed, and you'll see them dripping. I've only ever had it one time. I've shared the story on here before, and it's one that got. Actually, I believe it was going to your state, and it got lost in shipping for 14 days, and it arrived alive, and the guy's like, "Hey, I got it," and it's all sweaty, and I was like, "Do not touch it.
No,
Just
no.
dump it
Oh,
in a
man.
bucket of water and let them swim around for a bit, rehydrate." But there's a gardener. Well, speaking of like just animals developing immunities, the only thing that eats them is the red-side coastal gardener snake out on the west coast, and there's like I remember each newt can kill 140 people or a couple blue whales with how toxic they are, with how much tetrodotoxin they produce.
Yeah,
But-
that is insane. Yeah,
You'll see these little-
That's an aspect of what they call an evolutionary arms race. Essentially. Yeah.
And gardener snake will sit there and eat 3 of them, and it seems like it's on a 60-year period. A lot of biologists agree where the gardener snake will develop a little bit more toxicity resistance, and then the newt will then they'll die off a little bit. Then what survives gets more toxic, and then
There we go.
What doesn't?
That's exactly
now you have
right.
a newt you can throw in a water tower.
Yeah.
Yep, yep. I have an anecdote for you. This is probably apocryphal or something like that, but people apparently learned that certain newts and salamanders were toxic because they found like a group of 2 or 3 cowboys dead in the field, and they had like a coffee pot boiling, and there was a newt inside. They boiled their coffee with a
Yep.
newt.
That was a
And they
rough-skinned
poisoned
newt.
them. I don't know if that's true or not, but it's not so far-fetched.
No,
So-
that's happened. That was a rough-skinned newt that happened with.
Okay.
The species, and why I loved them is they're really confident. They know how poisonous they are. So in captivity, like they're super excited to be fed. They're really pretty. They're fire truck red on the top and like stop sign yellow on the bottom, and they show their bellies. They do little push-ups. They're always
That's
swimming
awesome.
around. But if you ate one, it would kill everybody you know. But yeah, it's happened. The last death, though, they haven't killed somebody in a long time. The last death was in California, and it was like the 80s because a guy ate one on a dare at a bar.
Oh my god! Oh no!
And he got free drinks for the night, but he never finished his first beer.
I wonder why.
Yeah, he swallowed the most toxic vertebrate on the planet.
Yeah, exactly.
And you'd have better luck swallowing some radioactive waste.
You at least live longer.
You'd live a little longer.
Yeah, no, I'm telling you, as a dad, that terrifies me because My daughter, she was always a good girl. My 26-year-old boy, he's a pretty, relaxed guy. But the 22-year-old, he's a smartass, and he's like, oh my God, yeah, no, I cannot even imagine how would that be like.
You won't eat that newt, and yeah, I will.
Yeah, watch me. How much you want to bet?
Yeah, and then you don't realize you accidentally picked up. The reason that newt's not running away from you or hiding is because it's the most toxic vertebrate on the
world,
planet.
yeah.
It just doesn't care.
Because you swallow it. Then it cares.
Only idiots mess with it.
Yeah.
Or gardener snakes.
Gardener snakes eat them.
That's the one species that's the arms
Targets.
race. Yeah.
Gotcha.
No, that's awesome. And then I was going to mention it earlier, like lemurs. Haven't lemurs been documented with centipedes or millipedes?
Actually, that's one thing that I don't know how documented that is, but yeah, there's the slow loris.
Yep.
Okay, so I don't know if that's exactly a lemur. Again, I'm telling you, I'm not an animal biologist, so that but they actually seem to be the first venomous animal. Not animal, mammal.
Yes.
Essentially, because they have like in their teeth, like comb teeth, like really tiny ones, but they have like they are modified sweat glands in their elbows here, and they actually can lick. I cannot do that, but they lick their elbows and they coat their teeth with toxic substance, and they look cute, but they are nasty.
They're mean little things.
Yeah, you cannot put two of them in the same cage. They kill each other. Okay, so and then when they bite, they inoculate you with that toxin venom, which is very similar to the one that it causes cat allergies in humans.
Oh, okay.
Yeah, it's crazy. Nature can kill you. Will kill you.
It will kill you.
Any chance it can get.
Why were you laughing when he was talking about the slow loris?
Because we literally just brought that up about
2 hours ago on an episode.
Yeah.
Oh my!
It's just,
That's why he was laughing, because it was like word for word what we were talking about.
Yeah.
No, that's funny. But yeah, the slow loris, they are primates. They're very, very simple primates as far as primates go, but they are primates. But so are lemurs. Lemurs are very simple primates.
Yeah.
Right. Yeah.
Bigfoot's a manatee.
Yeah.
Sneak that in there.
Yeah. There you go. Got to get that one.
No,
in.
so we're about at the hour mark. I know we could probably go for many more.
I have time. It's up to you.
You got one more thing you want to add in for this episode? Then we'll just have you come back on. How's that sound?
Yeah.
Okay, absolutely, absolutely. No, I can come anytime you'd like. It's an honor and a pleasure for me to be here. Let me see if I can tell you one other thing about an animal on drugs. Oh, have you heard about and again, who in their right mind would do this? You know that octopuses, and I learned that octopi is also correct. It sounds cooler, but that they tend to be curmudgeons. They tend to be solitary animals, even though people have discovered colonies of them that apparently live in society. But somebody got into their mind to give them MDMA, ecstasy, to octopuses.
Oh, no.
Okay? So what they did, their hypothesis would be that in such an antisocial animal, the exposure to ecstasy will make them more mellow and social. And that happened. That's precisely what happened. Okay, so that serves to illustrate that even if they're invertebrates, we are not so different from other animals after all. In terms of our reactions to substances, how do we react to, again, pesticides, psychoactive substances? We are pretty much the same in that sense.
Yeah.
I love it.
And it's a good, with the things we put in our food, the things we put in our environment that animals consume that we eat,
We just had that conversation today, too.
Yeah. It eventually all comes back to us,
Absolutely.
Now,
Absolutely.
Before we wrap it up here, I would tell everybody where they can find your work, where they can get your books, where they can check you out. And I'll have all the links below like normal in the description.
Okay. Perfect. So I do have a website called boldscientist.com. for obvious reasons.
I can relate.
I'm sorry, I didn't mean to make you choke.
I about spit Dr. Pepper. I wasn't ready. Go ahead. Sorry.
Okay, so
BoldScientist.com.
there's links about my books and everything there. Sometimes I post things about research, and I actually have a podcast. It's called the Bold Scientist Podcast. That started in the pandemic because I hated teaching to a computer. I mean, I absolutely hate it. I need an audience, a live audience, okay? Because I have to be a little bit like a clown to wake my students up, as it were. So one of the things that it occurred to me was to make a podcast. So I'm reigniting it and doing stuff like that. But basically at the boldscientist.com, and all the information is there. And I will also send you my university's website where all my formal papers and everything are there.
Awesome.
Sweet. Perfect.
And everybody, please support him. Check him out. Listen to his podcast. Get his books. I know I'm going to be getting his books.
Absolutely, yeah.
I just want them signed. I have a little thing with collecting books that are signed.
I can hook you guys up with the books. So
Okay.
don't worry.
But no, thank you for coming on. I know I can already tell me and you could just talk forever about
Absolutely.
all of it.
Oh, yeah.
But, we keep them about an hour long, so this is perfect. You know how we like to end the show, where I'm going to count down from 3, and we're all going to scream bye, and then the outro will play.
Okay, I know.
All right. Ready? 3, 2, 1.
Bye.
Bye. Hey guys, thank you for listening to Cryptids the Corn podcast. Remember, the best way to support the show is share it with a friend. But if you are craving more of the J clones
And more from Mr. E.
there's always extra content on Patreon.
And our paid member space on cryptidsofthecorn.com.
We'll catch you next time with more exciting, fun, and informative information. Bye.